A very good afternoon, everyone. Welcome you all to this online NPTEL discussion class on Industrial Inorganic Chemistry. I am Madhuri Bhattacharya, Prime Minister Research Fellow in Department of Chemistry, IIT Madras. So this course has been taught by Professor Devashish Rai from IIT Kharagpur, Department of Chemistry. So this course is all about some important industrial inorganic materials, their production, purification and utilization. So today in this class we will discuss regarding some carbon modification, some filler materials like inorganic synthetic materials as well as natural filler materials, some inorganic pigments also. So these are my details and you can contact me over my email IDs for your any further queries or clarification. So yeah, coming to the first question of today's class. Which of the following can be used in making artificial heart valves and prosthetic devices? Glassy carbon, foamed carbon, pyrolytic carbon, none of the above. So pyrolytic carbon is the actual answer for our prosthetic devices and heart valves. Okay. Because this is the material similar to graphite but with some covalent bonding in between its graphene sheets. Okay, so graphite is not having any covalent bondage, it is having weak van der Waals interaction in between two sheets. But pyrolytic carbon, when we will offer pyrolysis to the graphite, then it will form some covalent linkage in between two sheets, leading to some imperfections in the production. So it is produced by the thermal decomposition of the gaseous or vaporized carbon containing compounds, and pyrolysis reaction takes place at temperature between 800 to 3000 degrees centigrade in both gas phase and on substrate subsurface. Isotropic pyrolytic carbon articles are used in health science as artificial heart valves and in making prosthetic devices. Because our body is made with hydrocarbon, several hydrocarbon, right? So the form of carbon that we can use in medical science, health science is pyrolytic carbon. Okay, then what is the range of temperature maintained in pyrolysis shown in the furnace black process? The temperature is actually 1200 to 1800 degrees centigrade, because this is the process produced by the reaction of a hydrocarbon fuel such as oil or gas with a limited supply of combustion air at high temperature. The furnace black process uses heavy aromatic oils at feedstock. Then the temperature range in the pyrolysis zone is 1200 to 1800 degrees centigrade. This gives a high yield and allows a wide control over the properties such as particle size or structure for various applications, from rubber reinforcement or rubber reinforcement to coloring. Several physical applications, physical properties can vary depending on the particle size and structure. Okay. Choose among the following. 1 gram of activated carbon has a surface area in excess of dash as determined by gas absorption. Activated carbon will have excess surface area of 3000 meters per inch. So activated carbon is a form of carbon processed to have small low volume pore size, so that there will be an increment in the surface area available for adsorption or chemical reactions. Okay. Due to its high degree of microporosity, 1 gram of activated carbon has a surface area in excess of 3000 meters square or 32,000 square feet as determined by gas adsorption, and an activation level sufficient for useful application may be obtained solely from high surface area. Further chemical treatment often enhances adsorption properties, like introducing some moiety that will enhance the adsorption, or some chemical treatment you can do to enhance adsorption property. What is the iodine adsorption number or iodine number of carbon black? It is actually the measurement of activity level of carbon black and defined as the number of milligrams of iodine adsorbed by 1 gram of carbon under suitable condition. It is called the iodine number. So number of milligram of iodine adsorbed by 1 gram of carbon under suitable condition. Now, iodine adsorption number of carbon black is in direct proportion to the surface area. As more the surface area will be, more amount of iodine will get adsorbed. So this is a measure of the activity level of carbon black. Higher number indicates higher degree of activation. Typical range is from 500 to 1200 milligram of iodine per gram of carbon. High iodine absorption number corresponds to a high surface area of the carbon black. Then the next question is about carburization process. What is carburization process? It is when carbon enters the surface layers of a metal or alloy actually. Carburization occurs when carbon enters the surface layer of a metal or alloy. The dissolved carbon remains in solution and reacts with metal to form carbides. Okay, metal will react with the carbon, dissolved carbon, and will form metal carbides. Both mechanisms strengthen or harden the surface of the metal. It is a heat treatment process in which iron or steel adsorbs carbon while the metal is heated in presence of carbon-bearing material. Longer carburization times and higher temperatures typically increase the depth of carbon diffusion. Yeah, as obvious, longer times carburization time and higher temperature will enhance or increase the depth of the carbon diffusion. Then what is or are the types of furnaces in a carburization process? Types of furnaces used: gas heated furnace, continuous carbon tube furnace, high frequency induction furnace. So all these kind of furnaces are used in carburization process. Where gas heated furnace is actually reaction mixture is placed in a graphite or fire brick crucible, and the combustion gas is also serves as a protective gas atmosphere. In continuous carbon tube furnaces, graphite tube aids as electrical resistance and in which the reaction mixture is continuously transported in boards through the furnace. Then hydrogen gas is actually served as protective gas atmosphere here. Then high frequency induction furnace. Here the graphite crucible is sealed under high vacuum and filled and heated with an induction coil coupled to a high frequency source. Temperature up to 2800 degrees centigrade can be attained in the high frequency induction furnace. Okay. Then which among the following is a natural filler with SiO2 as the main component? So the correct option will be quartz. Okay, the correct option will be all of the above because quartz, cristobalite, and then your tripolite all is having SiO2 as the main component and all are natural filler only. Fillers are fine particulated solids. This differs from inorganic pigments in their refractive index. So fillers and fillers and pigments will vary in the particle size. Okay, will vary in the particle size as well as in the refractive indexes. Like refractive index less than 1.7 versus vacuum will be for fillers, whereas pigments will have more than 1.7 refractive index. The fillers make a product less expensive and improve their properties. Silicon based fillers are considered as natural fillers. The examples are quartz, cristobalite and tripolite. Then what is the shape of novaculite pillar? Novaculite is also one kind of pillar. The shape is actually lamellar. Novaculite is a laminar shaped microcrystalline quartz. It has a high number of silanol groups on the surface and functions as active reinforcing pillar. It is commonly white to grey to black in color with a specific gravity that ranges from 2.2 to 2.5. It is also used in the production of sharpening stones. Okay. Then what is lithophone composter? This question, lithophone, we have also discussed in some previous class. It is actually the mixture of barium sulfate and zinc sulfide. So lithophone is a mixture of inorganic compounds widely used as a white pigment powder. It is composed of barium sulfate and zinc sulfide. It is an insoluble blend with organic compounds and confer opacity. It was made popular by the cheap production cost, greater coverage. Lithophone is produced by co-precipitation of barium sulfate and zinc sulfide. Most commonly, co-precipitation is effected by combining equimolar amounts of zinc sulfate and barium sulfide. Okay, like zinc sulfate and barium sulfide, we will co-precipitate, and then zinc sulfide and barium sulfate will be produced. combining these two. Then cadmium sulfoselenide. What is cadmium sulfoselenide? It is a solid solution of cadmium sulfide and cadmium selenide actually. So sulfoselenide is a compound containing both metal sulfide as well as metal selenides. Because metal sulfides and selenides have similar kind of crystal structure, they can exhibit some mutual solubility forming solid solutions. So solid solutions are like a crystal, a solid form that is having mixture of two materials but having a new kind of solid structure, that is called solid solution. So principle both are, but not as a liquid or solution that is having some solid kind of structure. So that is called solid solution. Now cadmium sulfoselenide is a solid solution of cadmium sulfide and cadmium selenide. Cadmium sulfide is yellow, whereas cadmium selenide is red. So the resultant sulfoselenides of cadmium are in between color, that is orange color. So yeah, that's all. So we have discussed some natural filler, carburization process, and about the different forms of carbon like carbon black, then your activated carbon and pyrolytic carbon in the uses of health science. So that's all. So far we have covered the important inorganic materials starting from this peroxide materials, bulk commodity materials, and then some nitrogen compounds, phosphorus, sulfur based compound, halogen compounds, their applications, some fertilizers like nitrogen based, potassium based, and some other like phosphorus based also, mixture of fertilizers also. Then some important metallic compounds, alkaline earth materials, alkali earth materials compounds, especially barium, calcium, manganese based compounds. Then industrially important some organosilicon compounds also. We have discussed like silicones, quartz, this kind of compounds in the application of like luminescence study. Then geolites also, some geolites are also silicon based compounds only. Then some inorganic fibers, then construction ceramics materials, enamels, then some different forms of carbon today we have discussed, some feeder material, pigments also. So yeah, that's all for this course. If you have any queries, you can ask me over the discussion forum, or you can mail me directly also in my email IDs. So yeah, that's all for today. Okay. Thank you.